The diesel engine trick that made torque without more fuel. Engineers moved an explosion 2 inches. 2 inches inside the cylinder. Same fuel, same boost, same engine. 40% more torque. They did not pressure, they moved it. The lie. Everyone thinks diesel torque comes from dumping more fuel. Roll coal, big turbo, crank up the boost. That's not how it works. Diesel engines run air-rich, 18-to-1, 20-to-1, even 25-to-1 air-fuel ratios. There's already more than enough air to burn the fuel. Smoke doesn't mean power. Smoke means you're wasting fuel. Incomplete combustion, unburnt hydrocarbons escaping his black soot. If smoke meant torque, freight trains would be rolling coal at idle. They don't, because torque doesn't come from how much you burn. It comes from when you burn it. The pressure timing principle. Here's what actually makes torque. Cylinder pressure, but not just how much pressure, where that pressure peaks in the stroke. Diesels generate insane cylinder pressures compared to gasoline engines. Passenger diesel, 140 to 180 bar. Heavy-duty diesel, 200 to 250 bar. Gasoline engine, 80 to 120 bar. Diesel combustion is a pressure monster. But here's the thing. You can have infinite pressure at top dead center and make zero torque. Why? Because at TDC, the connecting rod is straight up and down. There's no leverage on the crankshaft. The piston has nowhere to go but against compression. Maximum torque happens when peak pressure occurs 10 to 15 degrees after top dead center. Not during, after. That's when the crank throw has rotated just enough to give you mechanical advantage. Peak pressure lands there, and the explosion shoves the piston down with maximum leverage. That's the torque zone. And diesel engineers learned how to put pressure exactly there. So how did they control pressure timing? How do you move an explosion 2 inches without changing fuel quantity? Combustion speed. Fuel doesn't explode instantly. It takes time to ignite, burn, and generate pressure. In a diesel, that window is maybe 30 to 50 degrees of crankshaft rotation. Engineers controlled when combustion started and how fast it burned using injection timing, start the fuel spray earlier or later, piston bowl geometry, shape the combustion chamber to control flame travel, swirl, spin the air to mix fuel faster or slower. Change any of those, and you move where peak pressure happens. You're not adding fuel, you're choreographing the explosion. Inject too early, pressure peaks before TDC. The explosion fights the piston on the way up. You get knock, negative torque, destroyed rod bearings. Inject too late, pressure peaks when the piston is already halfway down the bore. No leverage, weak torque, wasted heat. The sweet spot is 10 to 15 degrees ATDC. Get combustion to peak right there, and you unlock maximum torque without burning one extra drop of fuel. Pre-emissions diesels, Cummins 12-valve 5.9-liter, Detroit diesel 2-strokes, mechanical injection heavy-duty platforms, these engines hit 25 bar BMEP. That's brake mean effective pressure, torque relative to displacement. Gasoline engines of the same era struggled past 15 bar. Pressure timing made the difference. Why they stopped? If diesel engineers knew how to make 40% more torque by moving pressure timing, why did they stop? One word: NOx, nitrogen oxides, the invisible killer regulators hated. Here's the problem. High cylinder pressure equals high combustion temperature. High temperature equals NOx formation. It's chemistry. Nitrogen and oxygen in the air bond at temps above 1400 degrees C. The hotter you burn, the more NOx you make. And advancing pressure timing, putting peak pressure at 10 to 15 degrees ATDC, raises combustion temperature. You make more torque. You also make exponentially more NOx. By the early 2000s, EPA and CARB regulations made high NOx combustion illegal. OEMs had two choices. 1. Keep pressure timing optimized and fail emissions. 2. retard timing to lower temps and meet regulations. They retarded timing. Peak pressure moved later in the stroke, 18, 20, even 25 degrees ATDC in some calibrations, further from the torque zone. Lower combustion temps, less NOx, and less torque. Not because the engine couldn't make it, because regulations wouldn't allow it. The durability excuse. OEMs also claimed they retarded timing for durability. And yeah, there's truth to it. Advancing pressure timing increases peak cylinder pressure, rod bearing loads, crankshaft stress, head gasket failure risk. Push timing too far, and you lift cylinder heads, spin bearings, crack pistons. But pre-emissions heavy-duty diesels ran aggressive timing for decades. Cummins 12-valve 5.9-liter, Detroit diesel 2-strokes, mechanical injection heavy-duty platforms. These engines hit 25 bar BMEP. The same engines also used the same high combustion pressure and torque metrics with insane reliability. These engines made 25 bar BMEP, ran 1,000,000 miles, and survived constant high-load operation. The difference? They were designed for it. Forged internals, steel pistons, robust bearing surfaces. OEMs chose to detune modern engines rather than engineer them for pressure timing. Why? Warranty costs. It's cheaper to retard timing and lower stress than to build engines that can handle optimized combustion. Torque took a back seat to spreadsheets. Modern diesels? Software jail. Here's what kills me about modern diesels. The hardware can handle it. Forged cranks, nodular iron blocks, advanced fuel injection. The engine is capable of running aggressive pressure timing. The ECU won't let it. Modern diesel calibration is shaped by NOx limits, particulate regulations, warranty fear, and global fuel quality variability. So engineers program the ECU to retard injection timing, push peak pressure later in the stroke, and flatten torque curves to meet emissions at every load point. The result? A diesel engine that could make 40% more torque at 1800 RPM, but won't because the software says no. Diesel torque isn't limited by fuel, it's limited by timing maps written to satisfy regulators. Proof it works? You want proof pressure timing works? Look at deleted diesels. Guys running tuned ECUs with emission systems removed. They don't add massive turbos or double the fuel, they advance injection timing by 3 to 5 degrees. Peak cylinder pressure shifts from 20 degrees ATDC back to 12 to 14 degrees ATDC, right into the torque zone, and the engine makes 20 to 30% more torque at the same fuel quantity. Same air, same boost, same engine. Different timing. That's not magic, that's pressure timing. It's the same trick engineers used in the 1990s before emissions regulations killed it. The engine always had the torque, it was just exploding in the wrong place. Why this matters? Diesel engines aren't weak, they're muzzled. The hardware is capable of making torque modern gasoline engines can't touch. But emissions regulations, warranty paranoia, and global fuel quality compromises force manufacturers to detune combustion timing. Peak pressure gets pushed away from the torque zone, not because it's better for performance, because it's better for NOx numbers. The irony? Retarding timing lowers thermal efficiency. You burn more fuel to make the same power. Higher fuel consumption equals more CO2. They reduced one pollutant by increasing another, and they killed torque in the process. Coming up, the piston bowl that controlled the explosion, why diesel smoke was never power, how EGR strangled diesel performance, the engine the EPA accidentally made legendary. Fuel didn't limit diesel engines, pressure timing did. And when regulators realized that, they made sure no one could use it.